right, so now when we draw the graph for that, if you draw a graph, 0, 0 is in the middle here, 0, 0. We have 1. So let us suppose that is 1, 1, 2, 3. We don't have that many, but yeah, 2, 3. All right, so 1, 1, 2, 4. So 2 is going till 4. Minus 1 is going till 1, and minus 2 is also going till 4. All right, so now when you join these points together, it gives you a parabolas. All right, so that is a parabola. It is symmetrical on both sides. All right, symmetrical on both sides means here when you fold the paper, so if you cut this paper and if you fold it, you will be able to see the same shape on both sides. Right, you'll be able to see the same shape on both sides. Cool. So that is an introduction of what a parabola is. So parabola is a symmetrical shape. All right, it is not a straight line, it's a curve, and it is curve up or curve down. Now, what does that mean of curve up and curve down? All right, so let's see. What if we have another equation, which is y is equals to minus x square? All right, so again, we'll create a table. Let's create a table. We have x and y value and so on. We will have values. So it's 0, 1, 2, minus 1, minus 2. All right, so 0 will stay 0. Now, if we have 1, so 1 squared is 1 and minus will give us minus 1. 2 squared is 4 and minus 2 squared is going to give us minus 4. Right? And then minus 1 square is 1 and that will give us minus 1 and minus 4 similarly. Right? So now when we draw this graph, we have 0, 0 right here. We have negative numbers, so we have to go 1 and 2, 1 and 2, 1, 2, 3, 4, right? So 1 goes till 1, 1 goes till minus 1, minus 1 goes till minus 1, 2, 2 goes till minus 4, and here is minus 4 as well, right? So this is 1, 2, minus 1, minus 2, minus 1, minus 2, minus 3, minus 4. And if you draw this one here, it's like that. Yeah? So here we can say it is still symmetrical. It is symmetrical, right? It is symmetrical in the middle. It has excess of symmetry. But instead of upwards, instead of opening upwards, it is opening downwards. So this is called concave up and this is called concave down, right? So when you have y is equals to x square, which is the positive number in front of it, it is concave up. If you have y is equals to minus x square, which is the negative number in front of that, it is concave down. All right, so that when you look at the equation, if the x square value is positive, you know it's going to be concave up. If the x square value is negative, you know it is going to be concave down. So it's like you identify straight away when you look at an equation, right? So that helps in that understanding. So now we know that when A, or in the curve, so y is equals to, so usually, so let's go back a little bit. Parabolas are usually written as y is equals to ax squared plus bx plus c. All right, if you're not familiar with this one, you can watch my previous video. It explains about the general form of quadratic or parabolas. Now here, if we see this value here is a, right? So right now for this video, we just need to focus on that a. So if a is greater than 0 means it is a positive number. So when it is a positive number, it is concave up, right? We just did that. Now, when a is less than 0, less than 0 means it is a negative number. So if it is less than 0, it is concave down, right? What happens when it is equals to 0? So if this is equals to 0, this thing a is 0, that whole thing goes away, right? You are left with bx plus c. So that means it doesn't remain a parabola at all. It becomes a straight line. So that is a straight line. It's not a parabola anymore. So if a is 0, it will give you a straight line. It will not give you a parabola, right? Okay, so now what we are going to do is we are going to shift the parabola. We're going to transform the parabolas, all right? So let's write shifting or transforming